Welcome to the review on relative formula mass. So what we're going to do in this little revision PowerPoint is to go through and understand how it is that we can actually calculate the formula mass using those atomic masses from the periodic table. So first thing we actually need to understand then is what the periodic table actually shows us. So in the diagram there, what we can see are the four key elements that we find out about from looking at any square on that periodic table. So first of all, we've got the name of the element there. We've then got its symbol, which is always going to be either a 1 or 2 letter symbol, remembering that the first letter is always a capital, and if it has a second one, it's going to be a lowercase letter. Then we've got the atomic number and the atomic weight. Now, one thing to notice is that the atomic weight will always be larger than your atomic number. Okay, so it's an easy way to identify it. Look for the larger of the two numbers in the box. So in this case, carbon's got an atomic weight of 12 compared to the atomic number, which is 6. Next thing we need to understand then is what a chemical formula actually tells us. Now, this will be a nice, easy 2-mark question on your exam paper in the summer. They will give you some kind of chemical formula, like we've got there with CaCO3. And then they're going to ask you 2 questions about this. First question is going to be how many elements are there in there, and what we need to do there is just count up how many capital letters we've got. It's that simple. So because we've got Ca, okay, C and O, then we've got 3 different elements. So we've got calcium, carbon and oxygen. So if it asks us how many elements there are, we would say 3. The second question they're going to ask you is how many atoms are there in that formula. So that's where we've actually got to look at the little numbers in the subscript positions to work out the total number of atoms for all of them. So what we can see there is, because it's just Ca on its own, that tells us there is 1 calcium. Same for the carbon, we've got 1 carbon there, but that little 3 after the O tells us that we have 3 oxygens. So what we actually have there in total are 5 atoms. So I've seen this question come up in 2 different ways. One is just to ask you the total number of atoms, so that's worth 1 mark. Second way I've seen it is as a table where you have to write down the number of atoms for each of the elements. So they give you a little table with Ca, C and O in it, and you'd have to write down next to it exactly how many atoms of each there were. And all they're looking for there is the number. You don't have to write any of the chemical symbols, purely the number. When we come to calculate the relative formula mass, then what we're going to do there is add up the relative atomic masses for each of the elements in that chemical formula. So this is a basic addition that we need to do to get our correct answer here. So again, as long as you understand the little rules of how to read a formula, then you should be absolutely fine and get top marks on this one. To give you an example then, they ask you a question along the lines of what is the MR, which means the relative molecular mass of water, H2O. So what we need to do first of all is understand that we've got 2 hydrogens, because it's H2, and 1 oxygen. Now usually in the question they will give you the atomic masses of any of the elements contained in the formula. So all we then need to do is add them up. So we've got 2 hydrogens which have an atomic mass of 1, so it's going to be 1 plus 1 and 1 oxygen there plus 16. So that gives us a relative formula mass of 18 for water. Slightly more complicated in this example. Question that we're going to have here is what is the relative formula mass of our magnesium oxide, which has the formula MgOH2. Now where we've got brackets, what that tells us is everything inside those brackets is times by the number just after it. So what we can see from that formula is we've got 1 magnesium, 2 oxygens and 2 hydrogens. So again we just use the atomic masses of each of those elements and then we add them together. So magnesium has the mass of 24 plus 2 of the oxygens, which is 2 times 16, plus 2 hydrogens, 2 times 1. So when we work all of that out, we get our final mass there of 58.